Hello students, welcome back to Effortless Chemistry. Already we have started group 17 of P block elements. In the last session we have discussed up to preparation of chlorine and their properties. Now we will discuss hydrogen chloride. Preparation and properties of hydrogen chloride, that is HCl. First point, preparation. It is prepared. It is prepared by heating NaCl, with H2SO4, sulfuric acid. This NaCl reacts with H2SO4, so that here 1 mole of HCl is formed, one hydrogen combined with Cl, so HCl plus NaHSO4. This NaHSO4 further combines with another mole of NaCl, so that there is a formation of sodium sulfate plus HCl, Na2SO4 plus HCl. So this is single step reaction and this is complete reaction. Here these two get cancels here, so that H2SO4 reacts with 2 moles of NaCl, giving sodium sulfate plus 2 moles of HCl. So this is the preparation of HCl. Next point, we will write properties. It is a colorless, pungent smelling gas. Next point, it can be liquefied to colorless liquid, which boils at 189 Kelvin. Next point, it is highly soluble in water. So in water it is highly soluble and it will ionize in water in the following step: HCl plus H2O. This gives, so this HCl is a gas. Whenever it is dissolved in water, it is highly soluble, so that it will dissociate into H plus and Cl minus on adding to the water. So that H plus is taken up by water to form hydronium ion plus Cl minus. This is in the aqueous medium. So for this step, the Ka value is 10 power 7. This Ka value indicates that this HCl is a strong acid in the water. So this HCl in water, it is called as hydrochloric acid. Always you keep in mind, suppose HCl gas is taken, it is not an acid, it will not give a single proton, because it is called as just hydrogen chloride, it will not give any proton. Whenever it is added to the water, suppose if I take HCl in the aqueous medium, then only it will give proton. So in the water only it is called as what? Hydrochloric acid here. Okay, next point I'll write. So in aqueous medium, HCl is called as hydrochloric acid. So in the aqueous medium only it is acid, in the gaseous medium it will not give a single proton also. Next point, higher Ka value. Ka value is what? Greater the Ka value, stronger will be the acid. Ka is dissociation constant for the acids here. So higher value of Ka of Ka, that will be equal to 10 power 7, indicates that HCl is strong acid in water. Okay. Next point, this HCl, it reacts with ammonia to form white fumes of ammonium chloride. It forms NH4Cl fumes. Here you will get white fumes of NH4Cl. Next point is the noble metals like gold, that is Au, and the platinum will not react directly with HCl. Already we know in group 15 nitric acid. So that also what happens here, these noble metals, they will not directly react with, if you take these noble metals gold or platinum, they will not directly react with HNO3 or HCl individually. Individually they will not react with HNO3 and they will not react with HCl. If these two are mixed, HCl and HNO3, these two are mixed, there is a formation of solution called as aquaresia. In the aquaresia, this gold and platinum both are soluble. So that aquaresia is used to dissolve the noble metal like gold and platinum here, because that aquaresia, it forms nascent chlorines, and that nascent chlorines, they will act on what? These noble metals here. So what is aquaresia? Already we have discussed in the group 15. Aquaresia, it is a 3:1 mixture of what? Concentrated HCl plus concentrated HNO3 in the 3:1 ratio. This is called as what? Aquaresia, which is used to dissolve noble metals. It is used to dissolve noble metals like gold and platinum. Now I will write the reaction between the aquaresia and noble metal like gold and platinum, because these are soluble in aquaresia. Okay. So the reaction between gold, platinum and aquaresia. So aquaresia, what it forms? It gives a nascent chlorine. Those nascent chlorine, they will act on the gold and platinum. Hence they are soluble in the aquaresia, but individually they will not react or dissolve with HCl or HNO3. Whenever HCl and HNO3 both are mixed, then there is a formation of what? Aquaresia. Whenever HCl and HNO3, they are in the 3:1 ratio, they are mixed there. So first I will write aquaresia. This is a mixture of HNO3 and 3 moles of HCl, 3:1 mixture. So first it will form what? That is on decomposition, it gives 2 times of water, these two, and this is NOCl is formed. This is nitrosyl chloride. After that it gives 2 nascent chlorine. Always you keep in mind, it is not necessary to write that nascent atoms. Nascent atoms are nothing but elemental atoms. They are highly reactive. We can write it in the square box, round box, whatever you want. Nascent means they are highly reactive, that's it. So now this gold, it will react with what? 3 times of chlorine. It will form AuCl3. Again this metal chloride AuCl3 reacts with 1 mole of HCl. What it gives here? HAuCl4 chloroauric acid. So in this one, these two get cancelled because here you have to multiply this one with 2, this with 3 in order to cancel these nascent chlorines. So here what you will get, 2 times of Au plus 3 times of HNO3 plus, and what else get cancelled here, HCl is there, and how many times of HCl, this is 3 3 is 9, and again this will be multiplied by 2, so you will get 11 HCl, because this AuCl3 get cancels here. Next, this side what is remaining, this is a 6 times of water plus 3 times of NOCl plus 2 times of HAUCl4, this is chloroauric acid. This aquaresia, first it forms a nascent chlorine, and these nascent chlorines are acting on the metal, hence these noble metals are dissolved in what, aquaresia here. Similarly, you can write the reaction of aquaresia with the platinum also. These are important reactions. Okay, so another mole of aquaresia will take, this is nothing but HNO3, this with 3 moles of concentrated HCl giving 2 moles of water plus 1 mole of nitrosyl chloride, plus it gives 2 nascent chlorines. So these are highly reactive chlorines here. Next, platinum reacts with 4 times of your nascent chlorine, it will form PtCl4. Next, this PtCl4 reacts with 2 times of HCl giving H2PtCl6, chloroplatinic acid it is. So now here 4 nascent chlorines are reacted and here only 2 are there, so just it is multiplied with 2 in order to cancel these nascent oxygens, nascent chlorines here. So what else you can write in this one, PtCl4 get cancels. Next, platinum plus, this is a 2 moles of HNO3 and 3 to the 6 plus 2, 8 moles of HCl giving 4 moles of water plus 2 moles of NOCl plus H2PtCl6. So this is a chloroplatinic acid. Chloroplatinic acid. This is what the reaction of gold and platinum with the aquaresia. So next point, it decomposes. Salts of weaker acids like carbonates, bicarbonates, and sulfides. So if you take Na2CO3, this on reaction with HCl will take 2 times of HCl, so that this chlorine combines with sodium, formation of 2 times of NaCl. Here one oxygen combined with 2 hydrogen, formation of H2O plus CO2. These two collectively can write H2CO3 also. Okay, suppose if I take sodium hydrogen carbonate, nothing but bicarbonate, this on treating with HCl, the sodium combines with this chlorine, this is NaCl, and this H combines with what, this hydrogen, 2 hydrogen, they will combine with 1 oxygen to form one water molecule plus CO2 is formed. Suppose if you take sodium sulfite Na2CO3, this on treating with HCl. So you take 2 moles of HCl here, it will form Na2, that is 2 times of NaCl, and this will be H2SO3. This is about HCl. So the next concept is interhalogen compounds. So what are these interhalogen compounds? Already we know that in case of group 17, fluorine, chlorine, bromine and iodine, all these group 17 elements are what? Highly electronegative in nature, and down the group atomic size gone increases, as a result electronegativity decreases down the group. So because of this difference in the electronegativity between these halogen atom, they will react with each other, so that they will form a binary compound, and those compounds are called as what? Interhalogen compounds, in which 2 halogen atoms are present here. So this fluorine is being more electronegative, it will react with chlorine, bromine and iodine, where chlorine, bromine and iodine, they will show positive oxidation state with the fluorine, because these are less electronegative than the fluorine. If you go for chlorine, chlorine is more electronegative than bromine and iodine. These bromine and iodine, they will show positive oxidation state with the chlorine, because chlorine is more electronegative. Likewise, what happens whenever 2 halogen atoms react with each other, interhalogen compounds are formed here. Due to electronegativity difference between 2 halogen atoms, they react with each other to form binary compound called interhalogen compounds. Interhalogen compounds, that's it. So simply whenever 2 halogen atoms react with each other, then a interhalogen compound is formed here. The general formula of these interhalogen compounds are, so what type of interhalogen compounds are formed here? So that is related to the oxidation state of group 7 elements here. That is, general formula is, first type, that is X dash is formed, and X dash 3, X dash 5, X dash 7 here. So these are the general formula of what? Interhalogen compounds. In this one, X will be larger halogen atom of less electronegativity, and X dash will be smaller halogen atom of more electronegativity. So this is what, for example, if you go for chlorine and fluorine, fluorine is more electronegative and chlorine is less electronegative, then this chlorine become as X and fluorine become as what? X dash here. And another important point I'll write here, as difference between size of 2 halogen atoms increases number of atoms per molecule. Increases. It means that as the difference between the size of the halogen atom, for example, if you take fluorine and iodine, these two are having large difference in their size. So the reaction between iodine and fluorine, they are having more number of atoms. For example, AX-7 type of the interhalogen compound is formed by iodine and fluorine. They are having IF7, so that it is having more number of atoms. So next point. Now we will write examples of each type of the interhalogen compounds. First one I will write XX dash, then we will write AXX dash 3, AXX dash 5, AXX dash 7. So in these interhalogen compounds, in case of AXX dash, the central atom is having oxidation state +1. Here it is having oxidation state +3. Here the central atom having oxidation state +5. In this case, central atom is having what? +7. One thing you keep in mind, always the central atom is a larger halogen atom which is less electronegative, and the surrounding atom must be smaller one and highly electronegative. Smaller the size of the atom, more the number of surrounding atoms here. Now in case of XX dash, so this is interhalogen compound. X is one halogen and X dash is another halogen. X dash is more electronegative and X is what? Less electronegative here. So what we will write now? See here, FCl Br. Fluorine is more electronegative than remaining three, so that central atom chlorine shows +1 oxidation state with the fluorine. ClF, BrF is formed and IF is also formed. Next, chlorine is more electronegative than bromine and iodine. BrCl is formed and ICl is formed. Bromine is more electronegative than iodine. Then another compound, that is IBr, is also formed here. So what are the example for this one? AXX dash, ClF you can write. Next, BrF you can write. Next one, IF also you can write. Next one, BrCl. Next one, IBr or ICl also you can write. Next, this one, IBr. So in all these interhalogen compound, you concentrate here the first atom which is a larger one, and next one is what? Smaller one. Less electronegative, more electronegative, like that we have arranged here. This is X and X dash type of the interhalogen compound. ClF, BrF, IF, BrCl, ICl. So the first one is less electronegative and the second atom is what? More electronegative. Next, in case of X dash 3, here also we can write another possibility, F, Cl, Br and I. ClF3 is formed. So the central atom is having +3 oxidation state, means surrounding it must be connected to the 3 atom. So that ClF3 is also formed. BrF3 is also formed. IF3 is also formed. And in this one, ICl3 also formed. And then BrF3 is also formed here. So these are the possibilities. First one is ClF3. Next is BrF3. Next is IF3 is formed. And next one, ICl3. Then another is BrF3 is also formed here. So these are the examples. Next, if you go for X dash 5, in that one, F, Cl, Br and I. This is a ClF5, BrF5 and IF5 is also formed here. Example, these are interhalogen compounds, that is a ClF5, so that the central atom will be in the +5 oxidation state, in the excited state. Next is a BrF5. Next is IF5. So in case of XX-7, only one interhalogen compound is possible, that is IF7. Remaining are not possible due to the steric hindrance. So that because of the larger size of remaining atom, there cannot be 7 atoms surrounding the central atom. So because of the small size only, 7 fluorine atoms are possible around the iodine atom here. That's why as the difference between the size of the halogen atom increases, what happens? The number of atoms per molecule increases. That's what I have given in the beginning. Now, preparation of, so in the next slide we will write preparation of these interhalogen compounds. You keep in mind these are the important example for interhalogen compounds here. So, we'll write preparation. So, except IF7, almost all interhalogen compounds are prepared just by the direct combination of halogens in an appropriate condition. So, what we can write here? Except IF7, all interhalogen compounds are prepared just by direct combination of halogen atoms in appropriate condition. Okay, so we'll take except IF7 you can prepare remaining halogens. So I2 combines with Cl2, you take equimolar. If you take equimolar, there is a formation of what? 2 times of ICl is formed. Suppose if you take chlorine in excess, suppose chlorine is taken in excess, there is a formation of what? ICl3. So 2 times of ICl3 is formed, means here you have to take 3 times of Cl2. The next one, you can take Cl2 combines with F2, so that there is a formation of ClF. If you take equimolar, if these two are equimolar, then there is a formation of what? 2 times of ClF is formed. Suppose if you take excess of fluorine is taken in excess, you take 3 times of fluorine, there is a formation of 2 times of ClF3 here. Next one, Br2 combines with F2. Suppose these two are diluted in water, then there is a formation of BrF3. 2 times of bromine, you take 2 times of BrF3, so that this is multiplied by 3 here. So if you take fluorine in excess, Br2 combines with F2, which is in excess quantity, then there is a formation of what? BrF5 is formed here 2 times, so that this is a 5 times of F2. This is what the preparation of interhalogen compounds. Now the properties of interhalogen compounds. All interhalogen compounds are covalent and diamagnetic in nature, because they do not have any unpaired electron. Diamagnetic in nature. all are volatile solids or liquids at room temperature except CLF, which is a gas at 298 Kelvin. Next point, interhalogen compounds are more reactive than halogens because XX dash bond in interhalogens is weaker than XX bond in halogens. But there is one exception for this one, except FF bond. So the point is always interhalogen compounds are more reactive than halogens because XX dash bond in the interhalogen, this is weaker than XX bond in the halogen. So weaker bond can be easily broken, so that they are more reactive as compared to the halogens. Example, ICl is more reactive than I2. Why? Because ICl bond is weaker than I2 bond, because ICl bond is weaker than I2 bond. So I2 is a halogen and ICl is what? Interhalogen compound. So the next point we will write. So the next point is the hydrolysis of interhalogen compounds. They will undergo hydrolysis. Interhalogen compounds undergo hydrolysis to give halide ion formed by smaller halogen atom and oxohalide ion formed by larger halogen atom. So one point you keep in mind, that is suppose if I take one interhalogen compound, that is XX dash, this is more electronegative small size halogen atom, this is a less electronegative large size halogen atom. So this will form halide ion and this will form what? Oxohalide ion. This on treating with water. So this one you take like this, because this is less electronegative, this is partial positive and this is partial negative. So H plus ion and OH minus ion, plus reacts with minus and this plus reacts with minus, so that there is a formation of what? HX dash plus HOX. So this is what? Halide ion is formed and this will be oxohalide ion, we call it as. This is halogen acid and this will be oxyhalogen acid. This is oxyhalogen acid here. So we will write the oxohalide ion obtained by different type of interhalogen compound if I write X dash, this on treating with water, in all the case halide ion is common, so it will give one halide ion plus one hypohalite ion is formed. Okay, in case of X dash you will get hypohalite ion, and halide ion is common in the remaining all type of interhalogen compounds. X dash 3, this on hydrolysis, again it will give halide ion, and in this case you will get this is halite ion, hypohalite and halite you will get. Next, in case of X dash 5, this on hydrolysis, again it gives halide ion, plus here you will get halate ion. Halate ion as the oxo halide ion. In case of X dash 7, this upon hydrolysis, again you will get a halide ion, this is common, and here you will get perhalate ion. So this is what the effect of hydrolysis on the different type of interhalogen compound. Now we will discuss the structure of different interhalogen compounds. Now we will discuss structure of interhalogen compounds. Mainly we will discuss X dash 3. So in this X dash 3, this is the central atom. Central atom is having what? +3 oxidation state, and this is also a halogen. So this is having how many valence electron here? 1, 2, 3, 4, 5, 6, 7 valence electrons are there. Out of 7 valence electron, 3 electrons are utilized for the bond formation with the another halogen atom. So 1, 2, 3 halogens are connected to the central atom, so that there is a formation of 3 sigma bond. Remaining 4 electrons, they are taken as what? 2 lone pair of electrons here. So X dash 3 type of compound, they are having here, they are having a 3 sigma bond plus 2 lone pair of electron, total is 5, so that hybridization will be sp3d here. So in this case, what is the shape of the molecule here? 2 lone pair and 3 sigma bond, they must be having T shape according to the VSEPR theory. So these are the 2 bonds which are present in the axial, these 2 are axial bonds, and one will be present in the triangular plane, and remaining 2 lone pair of electrons like this. So they are having what? This is T shape, and due to increased repulsion among this lone pair and bond pair, these bonds may slightly move towards this side, so that they may be having a bent T shape also. So in common we will write it as T shape. So X dash 3 type of the interhalogen compound, they are having what? T shape with the sp3d hybridization. So example for this one is BRF3. This is also given in the NCERT. So this bond is present, one is present above the plane and another is present below the plane here. So this structure can be explained on the basis of what? VSEPR theory. Those who have not seen that VSEPR theory video, just go through that one, so that you get perfect in the finding shape of the molecule and lone pair and bond pair of electrons here. Next, if we go for X dash 5 type of the interhalogen compound, in this one, this is the central atom which is having 7 valence electrons again. So all are in halogen means, so this will be 7th one. In this one, out of the 7, 5 electrons are utilized for the bond formation with the surrounding halogen atom, that is a small size halogen atom. So how many sigma bonds are formed here? Total 5 sigma bonds are formed, and the remaining 2 electrons, that is taken as what? Lone pair of electrons here. So they are having 5 sigma bond plus 1 lone pair of electron, total is 6, so that hybridization is sp3d2. So what is the shape of the molecule here? They are having square pyramidal shape, that is 4 bonds are present in the square plane like this, 1 bond is present above the plane, and this below the plane 1 lone pair will occupy here, so that they are having square pyramidal shape like this. This is what? Square pyramidal. Again this is based on what VACPR theory only we can say here. So the next one is AXX 7 type of the interhalogen. In this one the central atom is what here, this is again halogen, again 7 valence electrons are there in the halogen. Out of 7, all the 7 electrons are utilized for the bond formation with the surrounding atom. So for this one example is IF7. If you take central atom as iodine, surrounding atoms are what, fluorine here. So total how many sigma bonds are formed here? 1 2 3 4 5 6 7 sigma bonds are formed. So 7 sigma bond means hybridization is what here, sp3d3 hybridization. So it is having a pentagonal bipyramidal shape here. You can draw the shape of the molecule like this. So example is what for this one, IF7. Okay, so the pentagonal bipyramidal shape is like this. You have to draw a pentagon first. So this is your pentagon, and one bond is above the plane and another is what, below the plane. So these are the 5 bonds which are present in the pentagonal plane here like this. So the 2 bonds are present above and below the plane, and 5 bonds are present in the pentagonal plane here. So this is what I can write, this is a fluorine, 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 and this is fluorine. Structure is pentagonal bipyramidal, pentagonal bipyramidal. So the next one is uses of interhalogen compounds. These are used as non-aqueous solvents. First point, these are used as non-aqueous solvents. ClEF3 and the BrF3 are very good fluorinating agents. Used in the production of UF6, that is U plus 3 times of ClEF3. This gives UF6 plus 3 times of ClF. In this way these are used as what, very good fluorinating agents. So this is about uses of interhalogen compound, and this completes group 17 of P block elements.